All right, so number 2 goes a little something like this. Do you recognize, when you're walking down the street, if you're walking down the street and you see an animal coming the other way, could you probably recognize or identify that animal as a cat or a dog or an aardvark? Would you be able to tell the difference? Yes. Now, if you were walking down the street and mathematical graphs were walking at you, okay, first of all, you would run away. Secondly, would you know whether a square root graph or a parabola is chasing after you? Would you be able to identify them just by how they look? Would you be able to tell the difference between a square root versus a parabola versus a line? Okay, so that's the first part in identifying these graphs equations. So which of these graphs are x squared graphs? Name them by letter. Everyone. B, D, and F. All right? Just like you could tell the difference between a cat and a dog, you should be able to tell the difference between a parabola versus a square root. All right? Square root is half a parabola laying down, pointing to the right or to the left. Now, so which graphs are square root functions? A, C, and E. The next thing, if you've lived in your A, C, and E, that was correct. A. Okay. If you lived in your neighborhood long enough and you knew, like, which dogs lived in which house and which cats belonged to which neighbors, would you be able to tell whether they were, like, straying, like in the wrong yard? They're not where they're supposed to be. Would you be able to know? I mean, you would tell, right? Hey, that's my neighbor's dog, and it's up on West Liberty Avenue. That's not good, right? So my question is, can you tell that A, I know it's a square root function, can you tell that it's not home? Because normally, where is home for the square root function? The origin, and it kind of goes like that, right? Well, this graph isn't home. It's how many houses down, which way? It's 3 to the left. So for A, you have to say, I know that's a square root of x, but it's left 3. I've identified where it is. I can call the police or the authorities, and they can come and rescue it. All right? You want to talk about E, however, right? So E. The first thing about E is, can you tell that it just doesn't look right? Like A, it looks right. It was just in the wrong place, right? It wasn't home. Let's talk about C real quick. It's pointing in the right direction, so C is still the square root of x, but it's how many blocks down from where it normally lives? 4. Down 4. So it's minus 4 outside the parent function, okay? E, however, doesn't look right. So A and C were both walking in a normal direction. You know what I'm saying? Like they're pointing to the right. What's different about E? It's pointing backwards. So the first step in identifying its equation would be, how do you make the square root point the other way? Where? Because there's point the other way and there's point the other way. Good. Negative inside, negative outside. Which one's this? Negative inside. However, that's not all. Not only is this radical pointing the wrong way, it's how many blocks away from home? 2 right. And I bet you some of you said 2 right. And that's incorrect. If you graph that, it would go to left on your calculator screen, and you're like, what's going on? Here's one fix. If it's 2 to the right and you have a reflection, you gotta put that in parentheses, and it'll fix it. Square root of negative, parentheses, x right 2, x minus 2. That'll fix it. Or switch the minus 2 to a plus 2, and it'll shift it the right way. It's because of this intertwining of reflecting and shifting that you need those parentheses. Good? All right. Let's just continue down this path and finish the problem. How are B, D, and F, first of all, let's call these cats instead of dogs, because the square roots were dogs that were not home. These are cats. What's different about them compared to the normal cat that you see? So you're looking at all these cats running around your neighborhood upside down. That'd be weird. They're like running on their backs or something, okay? Well, how do you make it turn upside down? Take x squared and make it negative. So that's one thing that happened to all these graphs. They're negative x squareds. B is negative x squared up 4 blocks away from home. D is negative parentheses. It's how many units away from home? 2 left. Here's how that needs to look. Then squared. Very important. It goes in like that, or you won't have the correct transformation. What's going on? And finally, F looks like it's strayed from home. This cat walked away on its back. How far? Up 2 and, up 3 and right 2. So how do you do that? It's a negative parabola. Right 2, up 3. Minus 2, plus 3. Done. Okay? Identifying the graphs by what they look like. What's weird about them? How have they moved? It's all part of the process here.